Now let's solve this problem. If you need, you have to try to solve it yourself, okay? Please pause the video and try to solve it yourself. And then only what is the solution. There's a 5-digit number PQRST. PQRST. T is not 0, all distinct digits, or distinct digits, they are different digits. P is thrice T. P is equal to 3 times T. S is greater than Q by 4. S is greater than Q by how much? By 4. So S is equal to Q plus 4. While Q is greater than R by 3. And Q is greater than R by 3. How many such 5-digit numbers are possible? Okay. First of all, T is not 0. Okay, good. How many such values are possible? Is there any overlapping? P and T we have a link. S and Q we have a link. R and Q we have a link. I can basically connect these values. Okay, how to connect? Replace this Q with this Q. Instead of this Q, this Q I can put R plus 3. Then this will become S is equal to R plus 3 plus 4. S is equal to R plus 7. Okay. So this is another relationship, but it is actually a very important relationship. This actually important relationship is that PQRST, it's actually a 5-digit number. If this is a 5-digit number, that basically means that P, Q, R and S and T are 1-digit numbers. So the smallest value which they can take, like for example for P it is 1, for Q etc it is 0, because T, if it is a 5-digit number, P cannot be 0. And also, since it is saying that T is also not 0, it's mentioned in the question, T is not 0, then this value also cannot be 0. So these two values are not 0. It can be in values from 1 to 9, this and this, but QRS can be values from 0 to 9. If that is the scenario, let's figure it out. We can make multiple rules. I'm first going to make a rule using P equal to 3T. P equal to 3T. I'm going to make this rule by assuming the value of T. Okay. T cannot be P is equal to 3T. T cannot be 0. Let it be 1. If T is 1, P is equal to 3 times 1, and that is 3. If P is 2, then if T is 2, then this can be 6. 3 times 2 is 6. If T is 3, this can be 9. 3 times 3. But if T is 4, this will become 12. That is not possible, because every value should be 1 digit. So this scenario cannot happen. So just now I found 3 possible cases where for P and T are connected. It will come as a Cartesian pair. When the value of T changes, P also should change. So the values are 3, 1, 6, 2 and 9, 3. 3 possibilities here. 3 possibilities. Now if we look for S and R, okay, I'm going to try to make a connection for S and R. Q I will later add, okay, because it's anyway S, R and Q are kind of linked. Out of this, the one thing which I can know is that, see, Q is bigger than R by 3 and S is bigger than Q by 4. Basically, R is the smallest out of these 3. This Q, R and S. R is the smallest value and S is the biggest value. So I'm going to make a relation between S and R first. You'll see why it is happening. I will say that R is some random value. S is equal to R plus 7. I'm going to give the value. R can become 0. No one prevents us from doing that. If R is 0, S will become 7. If R is 1, S will become 7 plus 1, that is 8. If R is R can be 0, 1. If R is 2, S can become 9. If R is 3, then S will become 10. That is not possible. That's a 2-digit value. So this is not possible. So basically the values for R and S are in this form. And since I have the value of R, I can also find the value of Q. Q is equal to R plus 3. So I can say that Q is equal to R plus 3. So R can become what is R plus 3? Yeah, 0 plus 3, 3, 1 plus 3, 4, 2 plus 3, 5. So this is the combinations of the value. Let's write it in the order of this term QRS. QRS. QRS will be in the form. If Q is 3, R is 0 and S is 7. 0, comma 7. If Q is 4, R is 1 and S is 8. If Q is 5, R is 2 and S is 9. So that many combinations are there. Now there is one more problem. All the digits should be distinct. Okay, that basically means now we can put all of them together. P, Q, R, S and T. If let's put this value. If P is 3 and if T is 1, P is 3 and T is 1, then this value cannot be selected because Q cannot become 3 because we assigned the value of P to 3. We can give these two values for Q and R and S. Q will become 4, this will become 1, this will become 8, or Q can become 5, this can become 2, this can become 9. And these values are 3 and 1 again. So this combination is done. Now the next case, when P is 6 and T is 2. If P is 6 and T is 2, which all values can I take? This value, no overlapping is happening. So I can take that 3, 0, 7 for QRS. And also I can take this value 4, 1, 8. See, this is 6 and 2. But I cannot take this value. Why? Because the value of T is 2. It cannot repeat. They should be distinct. So that is done. Now the next case, if I'm taking this value, P is 9 and T is 3. Of course, here also I cannot take this value because 3 should not come again. Then I can take this value 4, 1, 8. Nothing is repeating. Or I can take 5 to 9. Oh, I cannot take this value because 9 is coming here, 9 is here. So I cannot take that value because all the distance should be separate. So only one possibility is there. Now just confirming once more if anything is repeating. Here I have to eliminate this value because I accidentally take a case where 1 is repeating. 1 is repeating, yes, right? Yeah. Now 3, 5, 2, 9, 1. Nothing is repeating. 6, 3, 0, 7, 2. Nothing is repeating. 6, 4, 1, 8, 2. Nothing is repeating. 9, 4, 1, 8, 3. Hopefully nothing is repeating. I'm looking carefully. I cannot find any values repeating. So 1, 2, 3, 4. Only 4 possibilities are there. Oh, it's actually a tricky problem. Okay, if I didn't make any mistake, please let me know. That's it, guys. 58 answer is B. Thank you.